So the solutions to the starter, I've got a red pen now, I've upgraded my whiteboard pens. So, the word equation. Hopefully you didn't need to check back to last lesson, but if you did, that's fine. And you will know, because this one I think is on your formula sheet, is that force is equal to change in momentum divided by time. That's how it's written on the formula sheet, so that's how I'm going to write it. So in a collision, there is a change in momentum because the object was moving and now it's not because it's crashed into something. And the time that takes to happen determines how much impact force is applied to the object when it stops. Now, the extra point that I need to make about this, which I'm going to write in another color, is that we say, and I'm going to write it here because I'm going to write the symbol equation along here, is that force, so green asterisk, force is equal to what we call the rate of change of momentum. Now, you might have seen the phrase rate of change before. You may not, and if you have, you may not remember. So what we mean by this is that the force is equal to, well, it literally means the same as this formula. Force is change in momentum divided by time. But what it means is that how fast the momentum changes determines the amount of force. So you could say that the amount of momentum change per second is the force applied. Now, obviously, we don't work it out like that. That's sort of a slightly higher tier, probably almost uni-level definition of it. But I would like you to write this phrase down, that force is the rate of change of momentum, because it's a phrase that comes up a lot, particularly in mark schemes, when it comes to talking about collisions and about how we affect collision. So I'm going to try and use this phrase a lot throughout the lesson, the rate of change of momentum. Please write that down. So now we've got our word equation. Our symbol equation is that F equals delta P divided by, I'm going to put in brackets here, delta T. So delta P is the change in momentum and T is the time. Sometimes we write delta T to show the time, like the change in time or the amount of time for the collision to happen. You can write it either way, and you may remember I mentioned this last time as a bit of a problem that you sort of can use both. I generally prefer to use T, but if you use delta T, you're not strictly in the wrong, and F, of course, is a force. You should know that. So, last part then is completing the sentence. If we increase the time for a collision to happen, then we say, therefore, that the force, how have I got some black on my red pen? The force, which we also call the impact, though that's not sort of the official term that's used a lot, the force or the impact decreases. So that's all you had to write there. You might have written it slightly longer form than that. That's absolutely fine. But when the time increases, the force decreases. So if we can make a collision last as long as possible, the impact force on, say, either the car or the object or the person is made as small as possible. And that's what really car safety is all about. If you can put that into a 2-mark answer involving this and that, you've practically cracked this little bit of the topic. So, let's talk about car safety, shall we?